Welcome to Sundar's lecture, and this is lecture number 17. What are the topics we have seen in the last class? See, we have taken a problem with the supernode. What is supernode? A voltage source will be connected between two nodes, so that we cannot tell what is the current in this particular branch. So what we have done, we have taken the current in this branch as X. That's all. That is what we have done, and we have applied KCL at node A, node B, node C, and we have found that it is I1 is equal to I2 plus I3 for KCL at node A, and at KCL at node B gives you I2 is equal to X plus I4, and KCL at node C we have found that I5 is equal to I3 plus X. So the unknowns I1, I2, I3, I4, I5s were found using the shortcut method that we have studied in the lecture number 15. Fine. Now what we will do, we just try to substitute the I1, I2, I3, I4, I5s in expression number 1, 5 and 7. Right. So I have taken all the expressions and I have written here. So we now try to substitute the values. First we will substitute 2, 3, 4 in expression number 1. So I will write that. So substitute 2, 3 and 4 in expression number 1. Fine. Now what we will get? So I1 it is nothing but 20 minus VAO. So 20 minus VAO should be equal to, see, I will divide it while substituting. I will divide these values so that it will be easy to add, or otherwise you have to take LCMs and all. Okay, fine, no problem. So what is I2? I2 will be 0.33 VAO, 0.33 VAO, and then what is that? Minus 0.33 VBO, and then you will have plus I3. So what is I3? I3, which is nothing but it is VAO minus 2 minus VCO divided by 4. So I will divide all these things. So you will get what? 0.25 VAO minus 0.5 minus 0.25 VCO. So you try to simplify this expression, bring all VO, VBO, VCO one side, and you keep constant at other side. So I will simplify this. So you see we are getting 1.58 VO minus 0.33 VBO minus 0.25 VCO, which is equal to 20.5. We will keep this expression as A. Now what we will do? We will substitute. We try to substitute. See, we will take fifth expression. So what we have to do? You need to substitute fourth expression. That is not fourth expression. See, we have I4 and I2. I4 is sixth expression and I2 is third expression. So 3, 6 in expression number 5. We have to substitute this. So if we substitute this, what we will get? What is I2? I2, we know that it is 0.33 VAO minus 0.33 VBO, that is I2, should be equal to X plus what is I4? I4 is 0.5 VBO. So this will be 0.5 VBO. Right, now what you will do, you just try to bring all the parameters, that means all the variables one side and constant to other side. So I am getting this expression, right? 0.33 VO minus 0.83 VBO minus X should be equal to 0. So that is I am keeping this expression as B now. So what we will do now, next thing, we will substitute I5 and I3 in expression number 7. So what is, so I will write here, substitute I3 is expression number 4, comma, I5 is expression number 8 in 7, in expression number 7. So what I will get now. So I5, that is nothing but it is a 0.2 VCO. So 1 by 5, that is 0.2 VCO, right? So 0.2 VCO minus 3 by 5 will give you what? 0.6. So that is 0.6. So I5 is completed. Next, that should be equal to x plus what is I3? I3 we have the expression here. So how will you write I3? So I3 will be 0.25 VAO minus, so 2 by 4 will give you 0.5 and minus 0.25 VCO. So you we try to simplify this expression now, and we are getting 0.25 VO minus 0.45 VCO plus x is equal to minus 0.1. So this I am taking this expression as C. Now you see we have three expressions, but we have four unknowns: VAO, VBO, VCO in expression A, but in expression B and C we have another uh, unknown parameter x. Now we need to eliminate any one of this parameter in any A in expression B or C. So now we will see that. So with the help of this expression, that is VBO is equal to VCO plus 1. Now what you do, you just substitute this ninth expression in, that is VBO, right? So we can substitute ninth expression in B. What you will get? Ninth expression in B, right? So B expression, that is 0.33 VAO, that we will write here 0.33 VAO, that has to be kept as it is, right? Minus 0.83 into VBO. Instead of VBO, what you need to do? VCO plus 1. You just substitute VCO plus 1. That's all. Now this will be minus x should be equal to 0, right? Now you simplify this expression, what you will get? 0.33 VAO minus 0.83 VCO minus 0.83 minus x will be equal to 0. Now if you further simplify this expression, you will get 0.33 VAO minus 0.83 VCO minus x, that should be equal to what? 0.83. You keep this expression as D. Now you see you have two expressions with three unknown parameters. You have expression this one, and you have another expression here. So now what we can do, we can add these two expressions. See, I will add these two expressions now. So we try to add these two expressions. So what we need to do now? Add C and D. What we can do? 0.25 VAO minus 0.45 VCO plus x will be equal to minus 0.1. So here you will get 0.33 VAO minus 0.83 VCO minus x will be equal to what? 0.83. Right? Now if you add these two expressions, I will get, so you see I am getting this expression 0.58 VO minus 1.28 VCO, which is equal to 0.73. See, you add these two, if you add these two, you will get 0, because plus x minus x will give you 0, right? So if you add these two, you will get this expression. Now what you do, you substitute this expression number 9 in A. So what we can do, we can eliminate again VBO. I will do that anyhow. So now you see we have taken these two expressions and we try to substitute 9 in A. 9 in A. So what we will get? We will get 1.58 VAO, that has to be there, minus 0.33. Instead of VBO, what you need to do? You have to substitute VCO plus 1. Then minus 0.25 VCO, that should be equal to what? 20.5. Now you try to simplify this expression. So if I simplify, I will get 1.58 VAO minus 0.33 VCO minus 0.33 minus 0.25 VCO, that should be equal to 20.5. So if you further simplify this, so if I simplify this, I am getting this expression. So 1.58 will be there and VCO, there are two VCO. So I have added these two because both are in minus symbol. Then this 0.33, I have brought this minus 0.32 to other side. So I am getting plus 0.33. And if I add this, I will get this. Now you see this is expression number F and you see expression number E here. Here you see expression number E. So both as VAO and VCO as unknown. Now you can simplify these two, right? So I will write that. Now you see I have written both expressions. Now these two expressions have two unknowns. So we can easily simplify this. So so that you will get what is VAO and what is VCO, right? So I am simplifying this. See, I am getting VAO is equal to 15.56 and VCO is equal to 16.48 volt. Now it is very simple because we know that because we know that VBO is equal to what? VCO plus 1. So you can easily find VBO, right? So VBO will be equal to what is VCO? 6.48 and I'm writing here 6.48 plus 1. What you will get? Simple. VBO will be equal to what? 7.48 volt. That's all. Now we have found what is VAO, what is VBO and what is VCO, right? All the node voltages has been found. Now it is very simple. We have seen already these kind of things, right? So here you see I1, I2, I3, I4, I5, all the current values. We have written already the formulas for all the current values, right? So what is I1? I1 which is nothing but that is current. What is I1? I1 which is nothing but current flowing in 1 ohms. I2 which is nothing but current flowing in 3 ohms. I3 which is nothing but current flowing in 4 ohms. I4 is 5. I4 is current flowing in 2 ohms. And I5 will be current flowing in 5 ohms. That we can easily substitute and we will get the answers. See, I have written the formulas now. So what is I1? What is I1? You come here. You see I1 which is nothing but it is current flowing in 1 ohms resistance. I2 which is nothing but it is current flowing in 3 ohms resistance. I3 which is nothing but current flowing in 4 ohms resistance. I4 is nothing but 2 ohms resistance. Current flowing in 2 ohms resistance. I5 is current flowing in 5 ohms resistance. So that is what I have written here. See, I1 is equal to current flowing in 1 ohms resistance and all these kind of things. So if I substitute all the values, VAO values, VBO values in all these expressions, I will get I1, I2, I3 and I4, I5. That I will write now. So we try to write the answers. See, I am going to find I1. So I1 will be equal to what? I through 1 ohms resistor. That is nothing but 20 minus what is VAO? 15.56. 15.56. So 15.56. So what is the value? Then you will get I1, that is nothing but I through 1 ohms will be equal to, so 4.44 amperes. Then what we can do? We need to find I2, that is nothing but I through 3 ohms resistor. Then what is that? That will be VAO minus VBO by 3, right? What is VAO? It is 15 It is 15.56 minus 15.56 minus what is VBO? That is nothing but 7.48 divided by what is that? 3. So if I simplify this, so I am getting that is I2 which is equal to I through 3 ohms 2.69 amperes. Now what I will do, I try to simplify for I3. I am just going to substitute for I3. So for that I will draw the, so for getting I3 which is nothing but what? I4, I through 4 ohms resistance, that should be equal to VAO. What is VAO? 15.56 minus 2 minus what is VCO? That is 6.48 whole divided by what is the value? It is 4. If I simplify this, so I am getting 1.77. So I through I3 which is equal to I through 4 ohms, that should be equal to 1.77 amperes. Now I will go for I4. That means I4 which is nothing but that is I through 2 ohms will be equal to what is VBO? Very simple. VBO is 7.48. That should be divided by 2. And I through 4 which is equal to I through 2 ohms, I am getting 3.74. 3.74 amperes. Now I will go for I5. For I5, what is the formula? VCO minus 3. What is VCO? 6.48 minus 3 divided by what? 5. So I am getting I5 which is nothing but I through 5 ohms resistor which is equal to, so I am getting 0.69 amperes. 0.69 amperes. Right. That's all, right? So we have found all the currents through all the resistors. See, so these are all the resistors. 1 ohms resistor, 3 ohms, 4 ohms, 2 ohms and 5 ohms. All the values we have found. And also you see by this method we can also find what is the current in this 1 volt source also. How can you found? How can you find that? You see, we know what is I2 and we know what is I4, right? So we can substitute in this expression to get what is X also. See, we will do that. So what is this? I2 is equal to X plus I4, right? I2 is equal to, see, I will write here. I2 is equal to X plus I4, right? So what we can do now, X will be what? Then I2 minus I4, right? I2 minus I4. What is I2? That is 2.69. What is I4? That is nothing but it is 3.74. So what you will get? 2.69 minus 3.74. So X will be equal to, I am getting 2.69 minus 3.74. I am getting minus 1.05. Minus 1.05 amperes. See, I am getting a negative value, so that what you can write here, this X is in the opposite direction, which means it will be this value. So this will be equal to 1.05 amperes. See, you see, we have assumed this. These current directions were assumed by us. If I am getting a negative value, then you can obviously change the current direction. But for all the currents, I have got positive values. Wherever you see here, I1, I2, I3, all are positive values, so that whatever the current direction we have assumed there, it is correct. But this X current direction, we have assumed it in the opposite way. So it has to be reversed. So this also you can find by this method, but it is not necessary. The question was to find all the currents in all resistors. Anyhow, we can also find this. So, this is the procedure to find all currents in a given circuit. That circuit is a super node circuit where it contains a voltage source between two nodes. So this is the simple procedure to find the current values. And also you see we have found this method by using KCL, right? And what we know, we can also find the currents by using matrix method. That will give you a better clarity towards the problem. Anyhow, that we will see in the next class. Thank you. Have a nice day.